All right, so here we are. We're now on part 2 of our intro to machine learning with Spark and Redis. And what we're going to do right now is take a look at a process called exploratory data analysis. All this is another way for us to take a look at the data that we've imported in part 1 of this tutorial. And we're now using the graphing functions within the Zeppelin environment. So let's get started. So click on 2, exploratory data analysis. And then your notes can actually show up on the screen as well. I've already run this once. If this was to show up to the first time, you'd have all the binders and the options for interpreters to bind to the note showing up at the top. Just click on Spark and Markdown. Just turn off everything else and say OK. All right. So on top of this as well, we can take a look at what's going on behind the scenes. So I'm just going to run our Docker exec it Redis 5 Redis CLI monitor. This will just show us what's going on while we're running our notes. Just make a little bit of room for this. You can see both on the screen at the same time. All right. So let's rerun the first paragraph. And the first paragraph, I'm going to refresh the page. So if you run into an issue where you can no longer see the code, it's just been because of the page size change. So just refresh and you'll get everything back again. All right, so in this first paragraph, we're using our data description language, the DDL, that we stored last time in the first notebook. So this is just basically a reintroduction to what that looks like. So we have Netflix data schema with dates. This is literally just the string values that represent the structure, the struct type that's backing our data frame that we're importing from Redis. So we're using the struct type from DDL convenience method to take this this schema and reapply it as a structure, which will now be imported from our Redis connection. And then we're going to create this temp view, which we did before, but now we're just going to call this one Netflix Redis because it's coming right from Redis for the use in this actual notebook. So go ahead and run this. Pending, running, finished. Perfect. All right. So let's basically take a look at what's our objective. And so our objective is to take a look at what kinds of trends and patterns we can find from the underlying data from this Redis data. Also, if we take a look at, specifically within the datetime columns that we added to each of the individual rows, we're going to take a look at how do things change over a year in the Netflix data set? What kinds of movies and television shows are more successful? What does the shape of this data tell us about the behavior of Netflix in general? Where have they been investing? This is basically the process of using data analytics or data mining to bubble up insights from your data. So we're going to take a look at investigating our Netflix data. So let's try and actually find these patterns. And one of the fastest ways I've found to be able to go and find patterns is a process called frequent item analysis. And frequent item analysis is basically a statistical way of taking a look at what shows up more often across like a body of text, or in this case, across individual ratings for television shows. So the frequent items algorithm is based off of the a priori algorithm, which is really well known as market basket analysis. So if you've ever heard of the Walmart diapers, basically story in general, they talked about diapers and parents who would go to buy diapers, they realized that if they put beer in your diapers, there'd be a lot more purchases of diapers and beer. And this was a really nice study that was kind of proving that if you move items together that fulfill a specific type of need, like potentially maybe being upset about needing to go buy diapers, maybe being upset about having to leave the house, who knows, beer helps everything. So we're going to take a look at how to actually use this frequent item analysis. So we're going back to our data frame, our Netflix data from Redis. If we remember from before, all we've done is load this, but it's going to be lazy executed the first time through. So what you see down below is basically just info level information about Redis being up and running, but we actually haven't seen it actually doing any sort of hash gets or anything else. But we're going to run this first, and now we're going to see some activity. Running. So we see lots of activity below. Perfect. we've now scanned through all of our data. We've actually extracted out our duration numeric and our rating across basically 25% or more support over all of our data. So that's what this column over here means. It just means this, we need a supporting body of evidence. So we take a look at this. We see that most content is between 51 minutes and 121 minutes. This kind of makes sense. 51 minutes used to be, 9 minutes of commercials for a 60-minute time slot. We now know that that's around maybe 40 minutes and 20 minutes of commercials, but times have changed. We can also take a look too and see what is the popular content. So we see TVMA, TVPG, R, and TV14. This is great. It's basically from young adult to very adult content. This is one of the areas that we can now say has 25% support within the data set, and it can basically start to influence some of our thoughts and intuitions about what's going on with the underlying Netflix data. So let's take a look at this a little bit more. So we have our frequent items, and now we're taking a look to see, okay, well, what does show up under TV14, TVMA, in types of movies? So let's take a look at the show ID, the rating, the title, and the country. So how are things kind of, what type of content, just to get an idea of it, is located where? Across India, Brazil, United States. You can go through that at your leisure. We're going to skip that for now. So this is basically just also showing different ways of looking at the data. How do we look through kind of a traditional BI way? If you're thinking about business intelligence tools, you have a SQL interpreter. So we're going to now select rating, release month, release year from Netflix dates, where release year is greater than 2015 and rating is not in TVMA or TV14. And it's Netflix Redis. Yay! All right. So if you're running any paragraphs and you notice that things might not work, I've started directly on Notebook 2. You have to run usually Notebook 1, Notebook 2, Notebook 3, Notebook 4, Notebook 5 in sequence to be able to ensure that the Spark context has all data behind it. If not, just go to the last data that you've actually loaded inside of that one notebook and just make sure you're referencing the correct table. In this case, Netflix data didn't exist, so Netflix Redis did exist, and we can use that instead. All right. So what this does is it says, given that we have a rating, a release month, release year from Netflix Redis, we now have an ability to basically pivot our table or pivot this graph around those different values. So this is one thing that I really liked about the Zeppelin environment was the ability to kind of quickly change the way that the graph behaved. So if we take a look at release year, we care more about release months. Great. So now it's release month by rating, and then we have this release year count. We can change this to just release month, and we're going to sum that. So then we can hide our settings. Let's go ahead and just stack this. So this basically gives us a way of kind of quickly analyzing, how content's actually distributed. So over the years, it looks like, well, January, no one really cares too much. February, maybe. March, okay. But it seems like towards the latter half, or think about H2, second half of the year, content's really popular. And then also when people typically have more time off for vacation, say in the States, think about from Halloween to Thanksgiving to Christmas and New Year's, a lot more content for people to actually binge watch. So you now take a look at this, over months and see how that actually stacks up as well. The other interesting thing, if you take a look, so switching this back to our initial release year, and now we're taking a look at this release year sum, then we can take a look now at the distribution of the data that we have in the data set as well. The other thing too that's interesting, if you take a look at the way that this content's actually stacked, remember this was not TVMA and not TV14. We can now kind of see the additional distributions. So let's go back over here. So right now we know that we have what's called a multinomial distribution. So normal distributions following more or less the pattern that we see in 2016 minus TVPG. So if we just remove TVPG from the graph, we can get, in some cases in 2016, more or less a normalish distribution. 2017, we have what's called a multimodal or bimodal distribution, because it looks like we have basically, in this case, we have maybe 3 camel humps. You could say it's 2 camel humps. And then from here, we basically have almost like even distributions, other than like these not rated movies. This is also most likely due to the fact that we're not reading a full data set. We're reading basically subsampling of 6,000 movies from basically the maybe around like 1980 to being early 2020. But the nice thing is that from here, you can basically just easily kind of click and change the distribution values, remove R from the set, remove not rated from the set. We're getting kind of more normalish distributions again in 2016, 2017. Content was more or less kind of purchased, across a nice curve based on the data. And you can basically do this forever. So we're not going to spend too much more time on it. All right. So now if we take a look at what else we can do when viewing the data, we're taking a look at the show ID and the type, which is movie or TV show, release year rating from Netflix Redis, where we care more about the year 2000 and beyond. So if we re-render this, we'll see basically the behavior change over time. So we take a look at movies and TV shows. And as you take a look, you'll see that there's almost this convergence in data towards 2019, where we have almost a 50-50 split between content. So if you think about like people's behavior from 2005, internet was okay. We had it. But as things became better, we had, 4K TVs, we had, a gigabit, and people also started basically not really leaving their homes and streaming more and binging more content. Movies become kind of a commodity. They're not released all the time. There is a huge back catalog of movies, but television shows are being made all the time. And they're easier to make, they're cheaper to make in general. So there's a lot more of that content. So in order to keep up with people's demand, television shows had to be almost an equal, expenditure for Netflix over time. That's at least what I'm getting from this data. You can read into it really however you want, and that's part of basically data exploration, is finding patterns and then also trying to prove that a pattern exists for a specific reason. Over here is just another way of actually kind of searching deeper. So we take a look at the distribution, so an aggregation of the count of total movies within TVMA, R, and NC-17, release year rating from Netflix Redis for release years over 2000. We're just adding this group by clause. So if we group by release year and rating, all we're doing is basically creating a bucket, and all content that matches both release year and the same rating will just fall into that bucket. And then this is also distributed over time. So total release year rating basically gives us our triple group by, if you consider it like that. And this allows us just to kind of view the breakdown of that content. So TVMA and R over time. So TVMA is huge. And every now and then you just have to kind of restack everything. I think there's some kind of race condition with some stuff, but regardless of that, it's really fun. It comes for free. There's no extra really additional graphing library to actually learn, which is great. All right, so what we have here is basically the solutions to the questions we asked. Hopefully you've been intuiting the same things that I've been intuiting as well. But the solution so far is saying, okay, well, if we have a question, we want to phrase the question of our data. What kind of content has Netflix been investing in? Right? What have they been doing? We've seen that they're really highly invested in adult programming and programming for teens. We got that from our frequent items distribution. So we had TVMA, R, TV14, and PG13. What type of trends have we seen over the years? Well, we've seen almost this convergence of an equal distribution of both television shows and movies. So is an equal distribution good? I think so, because I think that it just shows that, people's behavior has changed over time, and Netflix has been able to actually watch that change in behavior and adapt to it. So sometimes all we're doing with data exploration is trying to figure out, what can we learn from the data, and then also where do we have gaps in the data. So what we're looking at next is what seems to be missing. So what seems to be missing? We have a nice data set. We've added a couple other additional fields. So if you think about additional columns, we added with column to our initial imported data set that was cleaned. That gave us our date time. It gave us our release year, gave us our release month. From there, we also basically added information about our duration numeric and also our duration type, if we cared about was this movies or television shows, and do we care about the breakdown by minutes. This stuff can be used as a follow-up in the training as you kind of explore and go deeper into the data, kind of outside of what's actually already in the workshop. So some of this stuff is here as kind of a breadcrumb for additional things to look at. So for example, if you were to take a look and say, okay, I want to create a recommendation engine. I know that I like, say I like TVMA, and I really like foreign TVMA shows, maybe from the BBC. And I like maybe content that's around, 20 to 30 minutes per episode. So if I take a look at my history of television shows, like habits, am I watching more shows that are over 60 minutes or under 60 minutes? Are they over 30 minutes or under 30 minutes? What are the categories? From there, we can start taking a look at the actors that I might like or the directors I might like. Really, this data set can allow you to do a lot of things. But what actually is missing, which is kind of a low-hanging fruit, is the notion of categories. So we've taken a look at ratings like TVMA, PG-13, etc. But the categories also tell us a lot too. Is this a thriller? Is it horror? And a lot of this is also leading towards our ability to create a machine learning model that allows us to say, is this content safe for children or not safe for children? We're calling it basically kid safe. In the case of kid safe, as humans, we can easily read a label that says R. We can take a look at a director. Maybe it's Eli Roth. I know Eli Roth is not making content for children. He's writing horror and thrillers. He's a great, producer. He's a great director. I wouldn't, I don't have kids, but if I had kids, I wouldn't want them, wouldn't want them watching his stuff. Not until they're older. A machine learning system is basically just, it's a combination of heuristics, statistics that it's seen over time. It's not going to really understand who Eli Roth is. Doesn't understand horror. It just sees that this is, a string. So we're going to teach our system as we go through to identify what we want it to identify as a combination that is kid safe or not kid safe. And to do that, one of the first things that we want to start to do is basically break out these categories. So breaking out categories means that we have to actually go and continue to mutate our data. So there's a listed in column, and the listed in column, all it really is just a comma separated string. So that means nothing first in SQL because it's just basically a string value with commas. And then for us, there's nothing we can do with it because we can't really do a group by on string values because it's too complicated. We actually want to do a group by on a category field. So that's what we're going to do right now. We're going to take a look at how to split and explode our data, and then also do a copy and place pattern with our immutable data structure. So if we take a look at this Netflix data by category, we're saying I want to select show ID, type, rating, release year, release month. Now something fun. So we're going to explode. So exploding just means that if we have an array of values, so we're using a split operator by comma is going to say, well, this string had, say, 3 entities in it. So 3 different categories. When we actually split them, we now have 3 items in an array. An array is not a primitive that we want to work with in the SQL world, so we need to do something new with it. So all we're doing with explode is saying, for every unique row, which did exist, we're now going to create a duplicate row that just has one singular value for that category. So we're making more data, but in the end, we're going to be able to actually group by our category. So we can still find the show ID, and the show ID is going to basically take place within a category cloud. So if you think about like a word cloud or whatever else, but now with an association to a show ID. So this is the big part right here. So just the ability to basically explode, split listed in by comma as category. And then the magic will happen from there. So this is also an interesting thing too. So if we call the Spark SQL, we're now declaring that we want to use the Spark interpreter from the Spark DSL. Before we were just using it directly from like the Zeppelin SQL interpreter. And behind the scenes, it was calling the Spark session SQL. But now this allows us to actually continue to work with the Spark DSL, but maybe in a manner where we're only comfortable with a few things like adding columns. So here we're going to do what I was calling before, like the copy and place pattern. So we want to run this additional function. So if you think about a trim function, if you have comma separated values and you potentially have prefix or postfix padding on a string, and you want to now create unique words that don't actually have that string padding, you're going to use a trim function, which is going to basically snip off the white space around the word and just keep the actual characters. Could have done this with a regular expression, but trim is a lot easier. And it also comes as part of the org Apache Spark SQL functions package. So I'll just write that over here. Org Apache Spark SQL functions. The underbar just means import everything. So we'll just run this. So it's been run. That's perfect. I'm going to clean up this over here. So the interesting thing is that we did Netflix data by category. Great. That returns a data frame. It's also a promise that something else will happen with this later on. Because remember, Spark is lazy. So Netflix data by category with column category clean, which is our trimmed category. So the expectation here is that basically line 1 where it runs, so where we have Spark SQL, line 2 runs with column. We've now created a secondary column. We're going to drop the original category, and then we're just going to replace category clean with category. So all we've done is basically say category from the first pass might have extra white space. Let's create a container to hold our trimmed category. And now let's literally just move the data. So we're going to do a rename after removing one field. And all we're going to basically do, it's no different than removing the entire column from Excel and then adding the same column back with the same name. It's different data, same name, and at the end it doesn't really even matter. So it's just trimmed and cleaned up. So at this point, we've now created this Netflix categories. So if we change this over here, so if we now go and we say, I want to now describe Netflix categories. If I spelled it correctly, then we'll see show ID, type, rating, release year, month, category. This is exactly what we asked for, show ID, type, rating, release year, release month, and then category. So perfect, our operation worked as expected. The next thing, if you take a look at, say, total number of categories, this becomes an interesting thing because there's a notion of cardinality. So say you have more categories than you have content. You have the ability to basically do a group by one at that point, which isn't going to tell you much statistically about what's going on. So one thing that is usually important to do is take a look at the distinct number of total categories or the distinct number of total unique fields within a column of a data set or data frame in this case. So over here, we're saying this Netflix data by category, which we just created. I want to now select category, distinct. I want to sort asynchronous category. And now I'm just going to show the top 100 results. So it gives us an idea of everything that's actually available. If we were to just do a count instead of a show 100, we just see that there's probably around like 30 different categories, maybe 40 different categories. So it gives us the notion of categories as a unique set. So the big thing here is the actual keyword distinct. So we take a look at Netflix data by category. And we select the rating where the column rating is not null. So we knew before that we had the ability to actually have null ratings. We also know, because we did some fancy magic before, that we actually were filling in the ratings with our unrated. Where a rating was null, we filled it in with unrated because we don't want it to potentially be not kid-friendly and show up in kid-friendly. So if we run a distinct over here on column rating where it's not null, we're going to actually get the same total number of, so I'll just remove the where clause. So we just want to basically take a look at distinct. So we should have a clean data set at this point. We shouldn't have an unknown or a null rating. So we have that. Great. What we did in the first notebook actually worked. Wonderful. So we get basically the same idea. So if you think about, okay, well, we have low cardinality for ratings. We have fairly low cardinality for all of our individual categories. If we think about these as like an enum, from 0 to, say 30, from 0 to say like 17 or something like that, this is a way of basically saying, well, we can index these so we don't have to worry about these string values. And we're going to take a look at that under our feature engineering when we start doing feature engineering. Over here, though, we're going to now say, okay, well, I want to select total category from Netflix categories, where type is movie, group by category, order by category, async. What this will allow us to do is now see the distribution of categories from movies. And we can just literally kind of quickly view, comedies, documentaries, dramas, international movies, super fantastic. We have an understanding of the distribution of content within the movies. So this can actually help us figure out how things, how things could be kid safe or not kid safe. We're basically doing the same exercise we were doing before, where we care about like release here. We want to see how investment across categories is now been made over time. And this will allow us to just kind of take a look at that. So you see international movies have been really heavily invested in as Netflix went international. But we can take a look too next. Okay, well, dramas were super important. Lots of dramas. What else was important? Oh, documentaries. Okay, from documentaries, what else do we have? Oh, we have comedies. We know comedies show up all the time in Netflix. This is cool. So it gives you a way of basically taking a look at what are the kind of key categories or hot categories. What's trending. All right. So that's kind of that's that for basically the first part of this, exploring our data. We took a look at categories. We took a look at frequent items. We took a look at kind of a priori methods. Next thing we want to take a look at is basically using, instead of basically doing like a count start as total, we're going to take a look at other ways of doing aggregations directly in the Spark DSL. So if we take a look over here, we're saying, okay, this is going to be a data mining group. And data mining group is based off of something called a relational group data set. If you think about a relational database that has data, now you think about grouped data from a relational database. It's the kind of way to think about this data set. So Netflix data by category, we're going to group by release year, type, category, and rating. This is our initial primitive. And all this does is that once something is a relational group data set, it has specific functions on that data frame because it's now changed. So it's now a completely different primitive that has new types. So we take a look at the data mining group, we can say, okay, now I want to ag show ID as a count, now as total, and now I want to sort as descending total, and change this as mining Netflix. All this is doing is showing you the DSL versus having to use a SQL query to do the same sort of functionality. And then so if we take a look at data mining from Netflix now, we're going to use a scatter plot. And a scatter plot's actually really interesting. Let me move this over right over here so we have more room on the screen. But the scatter plot allows us to take a look at basically lots of high density content all on the same screen. So now we can take a look at basically from 1940 to 2020 for release years of movies across content. How has it actually kind of changed over time? And a lot of this just basically proves that it is TV MA and TV PG. That's kind of basically more exciting. We also see that we have more kid safe. So TVG, we have more, it's PG-13. It's safe for some. TV PG, safe for kids. TV 14, safe for some. TV MA, great. And here's kind of another way of basically taking all of our data. So as we're finishing each of these individual notebooks, we are going through an entire exercise, and then we're going to save the end result of our kind of, our time back into Redis. And this is a nice way of being able to say, well, we had a lot of complexity, and as we reduce complexity or we change basically the view of our data, all we want to do is basically store it back to Redis as a convenience method. This allows us to basically short circuit the process of going all the way back to the initial, say, CSV import. But instead we're saying, well, we've done a bunch of work. Now we've stored a view of the data. All I want to do is start off with that view of the data and now add to it. So that's all we're doing right here. So we're basically storing the show ID, the category, and the rating, because this allows us to have a reference table or a join table for us to be able to say, okay, well, this show shows up in this category and this rating. We don't really care too much about the title and everything else about the show because we can join with it later. So it's less data and it's less processing that needs to be done in the Spark, within the Spark runtime. So let me just run this, and you're just going to see the output in the Spark monitor. So we're basically deleting what was there before because we already run this, and then we're just overwriting it. So you see that overwrite just happened right there. If we remove the overwrite, and say we do this error if exists, then all we have to do is run this and we get an error. Yay, because it was already there. So it's basically saying, well, I'm going to scan and match. So if this exists, don't do anything with it. So now move back to this overwrite. So we just watch that happen again. So it's really nice to be able to have the Redis CLI out so you can watch all the operations that are occurring basically in real time. All right, so this is just so basically taking the data that we just stored in Redis. We're just going to basically pull it back again. This is literally just an exercise to be able to just move data around with comfort from the Spark through Zeppelin. So we're doing the same thing we've done before, create a DDL. The DDL is now going to be reading out that new schema, which is our show ID, our category, and our rating from before, show ID, category, and rating. And this allows us to also store this struct. Say we were going to release something that goes to prod. Then all of these structures could be versioned in a package, say, in your jar. You've compiled it down. And now if you're going to change anything else in the entire pipeline, or you're going to change the way that you've actually written to Redis, all you have to do is basically just create a new version package and go ship that. And then everything is basically going to be in sync from there. Because one of the worst things to happen when you go into the streaming world is that you have stuff mutate from underneath you and you have no idea why it mutated. And that's really hard to debug. So in this case, if you basically know exactly what describes, what's the structure of all the data that you're working with ahead of time, then something can run in stream, no problem. So we have the Netflix category and rating. I just want to run it like one more time. Great. As we see before, I'm going to do that one more time. So as we, I guess I'm going to, basically kicking a horse at this point, but run this again, we'll see nothing happens. Great. Again, Spark is lazy. Only when we actually select everything will Spark actually go load memory into this view. It's basically creating a view of our data, and the view is a snapshot of what exists at the time that you actually load this. So if you were to update what was in Redis and then run this again, because you haven't cached it off, you could actually have a different process updating your database. So you could add more movies, more content, more categories, etc., and kind of keep on going from there. So that's pretty much it for part 2. How do we explore data, and how do we actually investigate what to do with the data to kind of extend the surface area of what we can actually investigate? So we took a look at the distribution of basically TV shows and movies across ratings, and we've seen basically what are the most popular ratings, and also how has Netflix changed over time, basically going from a 25-75 distribution between movies and TV shows now to basically a 50-50 split. We also saw that basically PG-13 to TVMA was more popular than children's content. We also saw that international movies were on the rise. So there's a lot of interesting stuff that can happen when you start to explore the data, but you can also realize that there's more that you might have to do. So the exercise of getting to the ability to have categories was just one example of how do we actually mutate our data in order to solve a problem. So that's it. I hope that you've liked this so far, and we can take a look at part 3, which is feature engineering, where we're going to take this problem and start getting it ready for actual models. So versus things being ready for humans, we're now going to be preparing for machine learning. Thanks.